Earth observation is the process of studying the Earth and its environment through a technique called remote sensing. This is basically making measurements of electromagnetic radiation, and in terms of Earth observation, we're doing that from Earth-orbiting satellites. The simplest type of instrument that we perform Earth observation with is a standard visible camera. So you can see here this astronaut photography from one of the Apollo missions to the Moon, where they've taken this stunning image of the Earth. You can see the continents, the oceans, and you can see cloud patterns. But we can now design instruments that are sensitive to a much wider range of wavelengths than simply visible light. And with that, we can tell a lot about the Earth and its environment beyond what we can see with simple photography like this. So the Earth is a complex system, and we want to measure and monitor the climate and the environment of the Earth in as much detail as possible. The only way to do that from scales at the local to the global is through Earth observation satellite technology. We can design individual instruments and missions that can target the geophysical properties of the Earth. For example, to measure leaf area index of plants, we can use instruments working at visible and near-infrared wavelengths that respond to reflected sunlight. If we're interested in land surface temperature, we can measure at long-wave infrared wavelengths, where we're measuring the thermally emitted energy from the Earth, and from that inferring the Earth's surface temperature. Orbiting the Earth at any one time are hundreds of satellite remote sensing missions operated from control rooms such as this. Those missions have been designed for a particular task, and each carries a dedicated remote sensing instrument that's designed to measure a particular property of the Earth system. There are two main categories of remote sensing instrumentation: passive and active. Active instruments generate their own electromagnetic radiation, direct that of the Earth, and then measure what comes back to the instrument itself. Passive remote sensing instruments use the Earth as a source of electromagnetic radiation, either emitted radiation, which is usually at longer wavelengths, or shortwave radiation, which is actually reflected sunlight. Sometimes space agencies mix passive and active instruments on the same platform. So we can see here, for example, Sentinel-3. It's a new satellite from the European Space Agency, and it has an active instrument on board in the form of a radar altimeter. This uses microwave pulses to measure the height of the ocean surface, for example. And it also has a couple of instruments on board that measure reflected sunlight and thermally emitted radiation from the Earth's oceans, clouds, and land surface. These days, Earth observation satellites come in a wide variety of sizes, from CubeSats that are about this size to large missions like this, which is Sentinel-3. You can see on this animation the general features of a typical Earth observation mission. There are solar panels to generate electricity, antennas to communicate with the Earth and to send the data down, and here are some apertures which are to let electromagnetic radiation into the instruments themselves. To observe the Earth's surface from space, we have to look through Earth's atmosphere, and that has impacts on the electromagnetic radiation, generally in the form of scattering or absorption. In the case of scattering, the sunlight is scattered into different directions, and so the path of the radiation is changed. Typically, the scattering is more severe at shorter wavelengths. That's why we see the sky as blue, because sunlight is being scattered in the atmosphere preferentially at shorter blue wavelengths and seeming to come from all directions. The satellite era started around 60 years ago with the launch of Sputnik, and now it's reached such a level of maturity that there have been hundreds of missions, and you can control a ring of geostationary satellites orbiting 36,000 kilometers above the Earth from a single room with a relatively small number of people.